Hello and welcome back. In this session, we are going to implement the algorithm to detect whether a given number is happy or not using Python. Here is the problem description. We went through it once before for Java. Here we will quickly go through it one more time. So the problem is write an algorithm to determine if a number is happy, and then how do we know whether a given number is happy? If let's take an example. I think that's the faster way of doing it. For 19, for example, the two digits are 1 and 9. 1 squared plus 9 squared, 82. That's a new number. And now we repeat the process. 80 squared plus 2 squared. Now it gives 68. Now we have two digits, 6 and 8. 6 squared plus 80 squared, 100. Now we have three digits, 1. Well, we have 2, but with repeat, 0 repeat. 1 squared plus 0 squared plus 0 squared. This is 1. So it came down to 1, and it doesn't change any further from here. So this is a happy number. Okay, so that's what it is, and that's what we need to find out. With given a number, whether 19 or any number, we need to find out whether that number is happy or not. And in the algorithm, in the process, we use kind of comparative. We take a number, and in the process one would be, we start with the number like 19, and another reference, another like parallelly two items will move forward in our loop. Another will be next to 92, which is 82, right? If it's a happy number, the one that's with the 82, that starts with 82 is going to terminate faster, right? So, and if it's not a happy number, then it'll form a cycle, and at some point uh, they'll meet some common numbers, and then that's when we exit. So time complexity. So in order to find the next value for a given number, it has a cost of order of log n, as we need to process each digit in the number, and the number of digits in a number is given by log n. We are not using any additional space. That's why it's a constant space represented by order of 1. That's a quick analysis of it. Let's go to our editor and do the Python implementation, the most important thing, the implementation. That's what people need, when we apply for any kind of software engineering roles. They like to see running code. That's the important thing. Okay, vi happy happy is happy number dot Python. So there is a Java implementation. That's why I got that completion. Set number, right? Cool. What is the deal here? Dev get name. Okay, we need to implement this. We need to get the next number, right? So we need to implement that first, and that one, sum 0, and while num is greater than 0, we do something. What is that? Python allows us to do two operations at once, div and mode. We need div and mode. We need the quotient and the remainder. Okay, first one gives the quotient, div, and then mode. It returns two things, two items. Here num is divided by 10. The quotient goes to num, and remainder goes to digit. Okay, and we are going to have sum. This is my, let's close it. We're going to have digit sum, digit square sum. Okay, this is the square in Python, and once you return, we return the sum. Okay, that gives us the next number in the chain, in the algorithm for 19 that we saw before. That's how we calculated 82 from 19, right? 1 and 9, right? All right, so let's now our method to detect that is happy, and we again pass number, one particular number, and how we detect that. We have two like parallel runners, slow runner, which starts with the number, and fast runner starts with the next value. Okay, so that it can terminate faster, right? We have a way to compare. So here also we check something. Okay, we continue this fast runner is not equal to 1, because if it's equal to 1, then we know that it's happy. Okay, so we need to repeat this. In order to repeat this, it needs to satisfy both of these conditions. Slow runner is not equal to fast runner, because if they go on infinite loop, because they do, if the given number is not happy, and at some point they'll have two matching values, right? At that point also we can just come out, because the it's conclusive at that point. Slow runner is equal to get next slow runner. Okay, we just get the next, because that's our calculation. We just keep going with the next number. And fast runner is equal to get next. We go one step ahead one more time. And fast runner. Okay, and when it's terminated, what do we return? We just return one check. Fast runner, whether we were able to reach to 1 or not. That's it. That's what accomplishes the implementation. I mean the core logic. And now we call it my num equal to 19. My result is equal to is happy 19. My num, and we print my result. And we need to do one more thing. If you remember, name is equal to main. We're going to call them main. It's more like a driver kind of thing. Okay, we're done. We're going to supply, and we'll fix error. Python. Yes, there is error, and it completes an ampersand sign. That ampersand, I think I just typed it because I just before this I typed Java program, so I remember that's how the AND is represented in Java. But here in Python, we will see, and is just logical AND is just AND, AND. Okay, all right. Python, one more. Yeah, that is also comes from Java. Oh, very interesting. Oh, my subconscious thing is doing this because we don't need bracket in Python. Okay, yeah, supply it. What is saying? Yeah, that is right, because I remove bracket. That means that space is not an issue, but you know, but if you see here, main thing is this column. We need a column, right? All right, I was just cleaning other stuffs there before column. All right, so now we supply to the interpreter, and it's true, and it kept true for 19, which is correct. Okay, so yeah, this completes the Python implementation. And if you would like to check for another number here, when I was talking, that thing was just running in my brain. So let me just show you another number real quick here before we stop the video. Let's do for 4. Well, let's do for 8 actually. Actually, if it's 8, yeah, why not? I mean, we can have any number. We didn't have to compile here. We just run it. Okay, 8 is not a happy number. Nice. All right. So this completes our Python implementation to detect whether a given number is happy or not.